Okay, let's now look at how we display vector data over raster data. We spent some time in the last lab looking at how the different ways we can display raster data, the different symbologies we can choose, gradiated color ramps versus individual colors, depending on what we're looking at, be it aspect, slope, or DEM. So what I've done here is we have our three main vector data sets. I've left out the aerial photographs, but we have our aspect data set, and we have our slope data set, and we have our digital elevation model, our primary data set. I've also now added three vector data sets. I've added a polygon data set, which is the outline of the counties of Ireland. I've added the Boyne River, a line vector here, and I've added the Ireland Towns data set. Now when you're displaying vector data over raster data, this question of symbology becomes important again, because depending on what your symbology of your underlying raster data set is, the symbology you could choose to show your vector data set will change significantly. An example here is that I've chosen this red dot for the Ireland Towns, and that works quite well because we have a grey, white and black background, and the river equally looks quite well because the blue stands out nicely against the black and white of the raster dataset. One of the things which doesn't show up so well is the outline of the counties of Ireland, and that's worth changing just to make it a little clearer. Now I would suggest, and you've got to play around with this and think what's best to yourself, I would suggest a strong black here, but play around with it, see. Similarly, you might choose to not just go for a hard line, but actually to change the outline itself. You can do that by looking through the various options you have down here of all the different things you can put in, or you can actually change the outline by going into properties. So let's make this a hard black broken line. We're given the option for outline here. Let's click on that. And you can see here that we're given all these kind of cartographic options and principles for showing this. So let's take something like, what will we go for? Let's take this boundary city line just to show you this example. We have a hard black color here, a width of 1, that's probably all about right. Let's go OK and just see how that looks. Okay, you can see this is taking some time because every time we reload the data page, it's reloading each of these rather large data sets. So it might be easier if you want to only add these as you're actually going to use them. Okay, great. So that makes, I think, that whole situation somewhat clearer. We have our digital elevation model covering County Meath and the extent of some of the other counties and administrative areas, but certainly covering all of it. We have our counties, our Irish counties data set, our river and our borders. So let's zoom in just to a part of this data set. Let's go into here. And we can choose, for example, to label these Ireland towns just to give us make the situation just a little bit clearer. Again, we're going to pick the town data set here because this is the attribute which has the name of the town. Great. So here we can see that we still have the label for County Meath on, and we can switch that off if we want to, but let's leave it there for the time being. Actually, let's change that slightly so that we can just differentiate that label from other labels. Let's go into properties. Let's go in labels here. Let's make that bigger and let's make it bold. Again, you can see every time we change something, it's reloading each of these data sets, which can take quite a bit of time. Excellent. There we go. Now, if we're interested in the relationship between a vector point and a raster point, there's a number of ways of doing this, but I'm just going to show you the most simple and basic way of doing it. Say, for example, we are interested in the properties of Navan, the topographical properties of Navan. Well, let's zoom into Navan now. And we can see that the point nav in here, this point is representing the town. Now in actuality the town is a lot larger than this, it has an extent. However, in this case it's represented by a point, and that is an issue because it means we're going to get a slightly skewed version of the kind of underlying data. But if we want to, for example, find out what's the elevation of Navan, we can do that just by using our identify tool. Now you see, if we were to click on the Navan point, we saw this in many of the previous things, we can see that what we've done is we get all the attributes associated with the Ireland Towns data set. But if we choose to, example, select down here that we want to look at the digital elevation model, which is the underlying model here, and we click here, we can see that Navan Town, this point of Navan Town, is situated at an elevation of 55 meters. Now that's useful because that gives us automatic topographical information about one of our points. If we were interested in what is the gradient of Navan, we could switch off the digital elevation model and we can switch on the slope. And we can see that Navan is situated on a kind of medium slope. Running down to the river, of course, the banks of the river, the slope becomes a lot more extreme. So again, we can use our identify tool and we can click here. Now at the moment we still have the digital elevation model highlighted and we want to look at the slope. If we click on that, we can see that the slope value for that point of Navan is 1.02 degrees. So it's situated on a very, very gentle slope. If we were to look at the value for the banks of the river, where it runs down to the river, we can see the slope gradient gets a lot more extreme. It's at 4 degrees there. And this will similarly work with aspect. If we want to turn on aspect, we could see what direction that particular part of the landscape is facing into. So let's zoom back out to the extent of our digital elevation model. Okay, so now we're back out just at our regional level. We're looking at our slope map and it's all looking a little clustered. In the next computer lab we're going to look at some of the best ways of creating a composite map showing several of these raster topographical layers. Specifically we're going to look at using multiple data frames like we did in the previous lab to show both these layers in the same map.